times 7. Okay, so welcome everyone. We're just going to try and finish off the warm-up, which is the Maths 24 question. So if you could pop your answers in the chat, and then it is now 6 o'clock, so we're going to get going. And I'd love to see an attempt from anyone who can get closer to 24 than me. At the moment, I've got 42, which is quite a far way away from 24. Who can get closer to 24? I'll keep an eye on the chat there.
So while they're doing that, we've got someone in our group. The name is Zoom user. And they can just pop me in the chat, just their name, just so I can rename them. It just makes life a lot easier when we're answering questions. All right, cool. Thank you.
Cool. So Zoom user, if you could just pop your name in the chat and we can then know who's speaking. So has anybody managed to get closer to 24? Anybody? So this is just our warm-up activity, guys, just to kind of get things going, just to get those muscles, those brain muscles loose. Let me see if I can get closer. So 4, what about 4 minus 1 is 3, plus 1 is 4 again. 4 times 7 is 28. So 4 plus 1 minus 1, and then times that by 7 would give me 28, which is closer. Anybody else got a guess to get us close to 24? Ms. Anya, have you got any ideas, any hints we can give the students to get us to 24?
I've been focusing on the chat, but I've got a slight hint. It has something to do with brackets. And somewhere you're going to say 7 minus 1. That's all I'm saying.
Okay, so the hint is there's a 7 minus 1 somewhere in the solution. That's what you need to look out for. Kiribona has got an answer there. Let's see if I agree with you. 7 plus 1 is 8. 4 minus 1 is 3. I think you're on the right track. Yes, yes, yes. So 7 plus, there's actually multiple ways to do this. So that's the wonderful thing about Maths 24. So 7 plus 1 is 8. So then we've used up those two. And 4 minus 1 is 3. And now if we go 8 times 3, we get 24. Woohoo! We are winning at life. Okay, so welcome to everyone who has now joined us. We're going to get going. And the topic for today is circle geometry. And it's our second lesson, or lesson 2 in circle geometry. And so that's going to be the main focus. But under the admin and announcements part, at the end of today, so probably at about 45 minutes past, 50 minutes past, we're going to do a fun quiz. And in order to do that fun quiz, you need to have logged in to the Watobe website, or have your login details for the Watobe website nearby. We will put the link to the quiz in the chat. But you don't have to worry about that now. But basically, when we put that link, we will say goodbye to you, and then you will go off and do that quiz, and you won't come back to class. Essentially, we will say goodbye when you go off to do the quiz, and then we will see you again on Monday. So are there any questions about the quiz before I get going? If you just pop it in the chat. Any questions about the fun quiz and how it works? Anything that you want to know before we get going? Okay, so I'm not seeing anything on the chat so far. Also, Miss Anya is, for those who are new, and I know there are some of you, Miss Anya will man the chat throughout, and so she will reply to any questions that I do not see. Hi, David. It is wonderful to have you back. And Oh, Miss Anya, hi, it's good to see your your video feed. That doesn't always happen.
Yeah, sorry, I'm just quickly saying hello for all our new users. So my name is Anya, or Miss A, or Miss V for Van Eden.
Yes.
My videos all for most of the call because my computer is getting old. But my eyes are on the chat the whole time. So if you're having any issues or if you want to ask a question, I will be in the chat. All right, good to see you all. Bye-bye. Well, I'm here, but you won't see me.
Okay, so just to do a little recap of what we did in the previous lesson. So a lot of people know about a circle, but we learned about very particular words that describe things in a circle. So most students will know about the words radius, diameter, and circumference. So, and those are pretty, clear things. So, the radius is the distance from the center to the edge. Often we use R. The diameter is a line through the center to 2 points on the circumference. And then the circumference is really just the perimeter of the circle. So we spoke about that. And we also spoke about two important formulas. The one was that the circumference is simply just this thing called diameter times pi. And so that gives us the relationship between the circumference and the diameter. And then we also spoke about new vocabulary like this. So what is something like that? For those who were here last time, can you tell us what is the line AB called? If you could just put that in the chat. Now it's not going through the center, but it has its own special name. So it's the chord. I see that. Yes, this line over here is called a chord. And then what I would like to know is, what if I focus on this area here? And I say, what is that called in fancy circle geometry language? A curved line from one point on another, on a circumference of the circle. What's the fancy word? I see it in the chat. Who else knows it? It is indeed an arc. So the curved line on the edge is an arc. This one across the center is a chord, the straight line. And then we spoke about a couple of other words, which we'll come back to. Probably the snazziest word. Let's see if, oh, didn't draw it right. Let's try again. So I have a circle and we have a line, and that line just grazes the circle and only touches it in one point. What is the line EF called? And what is the line EFGH? What is the line GH called? Put that in the chat. What is EF called? What is GH called? I see some people getting it right. Keep those answers coming, folks. Okay, so indeed, EF, the line EF is called a tangent. And that's because it only touches the circle in one point. And we call this point the point of tangency. Now, what is GH called? Not a GHD, no. So it's not a tangent, you're right, it's not a tangent. It's got its own special name. So a line that goes through a circle and it cuts it in 2 points. I'll wait a moment. Yes, Loratu, is called a secant. Yes, okay. Now, there were a couple of other words we spoke about, but those are the important ones. Oh, there was one more thing we spoke about. Okay. We used this funny word called subtend, and we spoke about if we have an arc on the circle and we make an angle over here. So let's call this that, and then we make an angle up here. Oh, what am I doing? Excuse my writing, guys. Let's make it. what is angle ACB called? Let me actually zoom in so you can all see. So what is angle ACB called? That will be this one over here. And what is angle ADB called? Should be this one over here. There's some special words. So I'm interested in the angle. What is this angle called? Over here, what is this angle? We use special terminology. Aha. So ACB would be the central angle or the angle at the center. So a central angle, or another way of saying it, if we use fancy geometry language, we'd say angle at center. Look at this fancy symbol I've used. So this little symbol means angle at center or central angle, and that's because the angle ACB is at the center of the circle. So that makes sense. We say that the arc AB, so maybe I should, the arc AB, that's this thing, it's almost like its base, subtends an angle at the center. Now that's very fancy language. We don't need to worry too much about that yet. But what do we have for ADB? ADB would be the inscribed one. Yes, the inscribed angle, or what we would say is we'd say angle at the circumference, and we use a dot. So again, look at this lovely symbol. That's the angle symbol, and we use the abbreviation circum with a dot, angle at the circumference. And why is it called the angle at the circumference? Well, look where the angle is. It's literally on the circumference. That's the point that makes it. And so we spoke about angles at the center and angles at the circumference last time. Okay, so now the focus today is actually going to be on bringing circles and straight lines together. In grade 9 and 10, you do a lot of geometry about parallel lines and what relationships happen when you cross parallel lines with another line. So relationships like that. You also do a lot of geometry of triangles. And what happens when you have triangles? What are the relationships between the different angles when you have that? And this is all straight lines. And we're going to do just a little bit of a recap of these ideas. And we're going to combine them together a little bit with circles. And so we're just kind of filling in any blanks that you have from grade 9 and 10 mainly today, and mixing it with circles a bit. So let's start with this question over here. And just to start with, I want to point out some language. So O is the center of the circle. There is O. And we also have an angle called V that we want to know the value of. And you need to use whatever geometric argument you can to get an answer. And when you get that answer, if you could put that in the chat. So you'd put 4A or 4B in the chat. And then I'll explain to you how we would do it using a full geometric argument. So what do you think the angle V is going to be? I can even zoom in even more. The magic of zoom. So what is this? For bonus points, if you know what the answer is, tell us what were the steps you took? Like what ideas or facts did you use? If you put that in the chat, what facts did you use? What did you use that you knew already? Like, what is this thing? This thing looks good. What does this mean? I think this might be helpful. So a lot of people are saying B. And so let's have a look. Well, I think that I know, and this is how we do geometry, we do it in arguments. I know that OBC would be 90 degrees because of angles on a straight line. And so in geometry, I'll do a whole lesson on reasons, but you'll often see like a bracket and you'll see like a little, so the angles on a straight line will always add up to 180. And so that will be 90. And now you know the angles in a triangle always add up to 180. But now how do I use the fact that this is 90 to help me? Well, I go 180 and I take away 90 and I take away 38. And that's just going to be using the sum of angles in a triangle. Don't worry about the reasons for now. I'm just throwing them up there. You don't need to know them yet. I will teach you about reasons later. And according to my calculator, because my brain is starting to get tired for the day too, I indeed get 52 degrees. So well done, guys. You are winning.
So,
okay. Yes.
Just to go back to the question, please.
Yeah.
If you don't mind.
No, all good.
Obviously, what's nice about geometry is there's more than one way to do it. I know Kitty Born in the chat also mentioned, well, they use exterior angles of a triangle. So that's also another way you could have done it, but either way you'd have gotten to the same answer. So that's actually what's quite nice about geometry.
You know what? That's even quicker. You know, that way would have been, I didn't even think about that. Theorem which says that the exterior angle, which would be this one, is equal to the sum of the interior opposites. And so you could have said 90 equals 38 plus V. And the reason would have just been exterior angle triangle. And so that actually would be even quicker and we get the same answer. So thanks for that, Ms. Anya. That was a good point and probably quicker. And I'll talk to you more about the structure. For now, I'm more worried about just doing the questions. I'm not going to do the reasons every time. So for now, we're just going to try and get the answers. So question number 5. What is angle A going to be equal to? How do we know that? I'm going to get some more water while you guys are busy. So just a shout out, I haven't greeted many of you, but to Apiwe, to Mbali, to Rua, to Dinkle, Nizole, to Blessing. Welcome, guys. It is really good to have you. Humela. It is really wonderful to see you or to hear you. Nowova, welcome to you. To Nez, welcome. Mati Daishe, welcome. I think I've welcomed Kwanda already. And welcome to Google Etu. Boitumelo, welcome. Okay. I see answers are coming through thick and fast. I think the most important thing with this is to realize that, are you still with me? Let's have a look. There we go. Is that these are both radiuses. And so if they're both radiuses, this is actually an equilateral triangle, which means that these two values must be the same. This must be an A as well. And so we know that 98 plus A is 180. And so in theory, if we use our knowledge of equations from the first module of the year, we take away 98 from both sides, and we're going to get 2A is, what are we going to get? 82. And then if we divide both sides by 2, we're going to get A is 41, which is that answer. Fantastic. Okay, good. Is it an equilateral triangle? It's not an equilateral triangle because we only know that this side and this side are equal because these are both radii. So the plural of radius is radii. And so because these two, this forms a triangle altogether, but the two base angles in an isosceles triangle will be equal. And so that's how I set up this equation over here.
So,
yes.
While we're on that note, something I also loved about our sausage triangles, if you actually look at Sir's drawing on the circle, if the two radar, if you think of Angry Birds, I'm sure you guys played or you watch Angry Birds. I always remember those two arms as being like the eyebrows of the yellow bird. If you can see what I see, those two lines being the eyebrows. And then the eyes at the bottom of those will have to be obviously the eyes, well, the corners, so that makes sense. So try to see as an sausage triangle, kind of like as an angry bird. That's also another way to remember it.
Yeah. Cool. Fantastic. Thanks. Okay. This is actually quite easy, but I'll give you a chance. Which line segment is the diameter? So there's lots of line segments here. Name the line segment which is the diameter. How do you correctly name it? Just a quick little one. So is it going to be FG? Is it going to be CO? Nope, it's going to be DE, which is this one over here. And that's the diameter. This one over here is a chord. And what you actually see is the diameter is also a chord, but it's a special type of chord. It's a chord that goes through the middle of the circle. So diameter actually belongs to the chord family. It's just a special one with a special identity. Okay, label the major arc CD and the minor arc. I think we've done this one before. So when we talk about the word arc, we actually divide the circle up into two parts, a major and minor arc. The minor arc is going to be the smaller one. So that would be the minor arc. And then the major arc is going to be everything else to go the whole way around the circle. So that's something which I'm just going to make you kind of aware of in terms of vocabulary. I think that's it. Okay, time to move on. So we've done a little bit of our circles. Let us go back in time to the land of straight lines and grade 9 geometry just to get up to speed. I would like you to do those two questions. And I want you to put the answer in the chat. So question 1, you were given this drawing here. And then you need to choose the correct answer and the correct reason. So which option corresponds to that? And then the same thing for number 2. So like I said, today is mainly just brushing up on some geometry from the past to get us up to speed for later lessons. And they're throwing some fancy words in here like complementary and straight line and all that. So yeah, put 1 something, 2 something for your 2 answers. So what relationship do the 120 and 2x have? I think the important relationship is that they're on a straight line and that they add up, anything on a straight line adds up to 180. And so my answer, if I took away 120 from both sides, I'd get this. And then divide both sides by 2, I get that. So I wouldn't get 30 because of complementary angles. Complementary angles add up to 90. The correct answer for 1 will be 1B. Okay, now for the second one, actually this isn't too bad. So what is the relationship between these 2 angles? Well, we call these vertically opposite, and vertically opposite angles are kind of like swords crossing. And you always get these pairs. So for example, this one and this one will be equal, and this one and this one will be equal. So x is 60. So it can only be either of these 2. And the correct answer is going to also be B. So this, guys, goes to your knowledge of geometry in terms of grade 9 and 10, and just making sure you don't have any gaps. So some of the common in fact, we're going to go through all the common theorems, but so far we've done angles on a straight line add up to 180, which is that one. And then this is vertically opposite angles are equal. Okay. I think that is that it? That is that from that one. Okay. So just some other little recap for a moment. Some terminology, some fancy words. So a point gets represented by a dot, and we name a point with a capital letter. So you'll always see capital letters. If we connect 2 points, we get a line segment. And then if you've got 2 line segments meeting at a point, these are called basically, those are called the arms of an angle, and they form an angle. And then the point where the 2 arms meet is called the vertex. So this thing over here would be the vertex. This would be one of the arms of the angle, and this would be the other arm of the angle. And then the amount of turn between the 2 lines is called the angle. Okay, so I think that's fairly familiar to a lot of you, but in terms of how we label angles, that can get a little bit confusing. So often if students, this is something which I've seen before, we shouldn't just call this angle angle A, because there's 2 angles at A. There's this one over here, and there's the reflex angle on that side. And so what we normally do is we either have 3 letters with a little hat on top, like that, or what is much nicer is we have little numbers like this, where we say, for example, the angle A1 is the same as the angle BAC over there. And so that is just the vocabulary that you'll see me using throughout the section. And I'm sure a lot of you do know this, but it's worth just clarifying. How do you name an angle? There's only 2 ways you can really do it. The one is by doing all 3 letters. It doesn't matter. Oh, this is important. It doesn't matter if you call it CAB or if you call it BAC. As long as the A is in the middle and you start with one arm and you get to the other, the outer arms don't matter. It's just where the vertex is that matters. Okay, so I thought that was a good thing just to go over. Let's move on to 3 questions. I want you guys to solve A, B, and C. And then I want you, as you do it, to try and give reasons that you remember from grade 9 and 10. So what are the reasons you remember from grade 9 and 10? And I want you to solve A, B, and C. And I will give you, these are quite, so I'll give you 3 minutes. 2 minutes, 2 minutes actually. So at 18:31, we will, I will give the answers. So we're just going back. What theorem or what geometric fact do we know that deals with this situation over here? Lerato, I think you're onto something. If you go a full revolution, how big is an angle? I think a full revolution is 360. And this looks like it's not quite 360, but could the 360 help me figure out what that is? I think it could. I think the answer has to be 360 minus whatever angle was there already, which is 310. And I would get 50 degrees. Yes, I would. Now, I'm actually not going to obsess about the reasons tonight. I will talk more, I will talk about the defined, but for now, I just want you to actually use the facts. So I get X is 50. Okay. All right. What about B? What do we get for B's answer? Could we use the same idea again to help me? Okay, so make sure you give in your answer, say like B, and then give the answer. Don't just say a number, because then I don't really know which one you are talking about. So I see an answer from Kitty Bona. It's come in. Can anybody else confirm that answer? Loratu has an answer come in as well. Let's have a look. So the one I'm looking for is here, but I need to actually know what all these ones add up to first. So 60 plus 70 plus 90 is 220. And so then I'm going to go 360 minus 220. And what do I get? I think I get 140. Now, it's the same reason again. Okay, the reason, so the reason that we often would, okay, I will show you this. We like to use abbreviations in geometry. So angles is the plural of angle, and it's just it's an angle symbol with a little S like that. And then rev is short for revolution, like a full revolution. See if you can do C. Notice how the questions are getting sneakily a little bit harder each time. Let's make that a little bit clearer. See, it's crazy. Yeah, you know why it's crazy? It's because there's a lot of variables. But ask yourself, has the amount of a revolution, the amount of angles in a revolution, has it changed? Is it any different from question B? If it isn't any different, if I add those up, I should still get 360 degrees. So think about how can I use that together with any other mathematical skills I have, for example, solving an equation. How can I use those two ideas to help me figure out, and again, the goal is to find the variable. So we're trying to find in the end, what is X? Okay, let's get those answers coming in. And guys, it's really important. It's not, everybody must be committing to an answer. So I want everyone to commit to putting your answers in the chat. Even if you get them wrong, the act of committing to something helps our brains kind of learn the right answer better. There's almost like a more dissonance if we commit to the wrong answer and then we see, oh, now I see it. We learn so much more than if we just passively observe. So please, keep putting your answers in the chat, even if you're getting them wrong. We know that this will help you learn as long as you're seeing the correct answer afterwards. Okay, so I see answers coming through. I'm going to say x minus 10 plus x plus 20 plus 2x gives me 360. And when we write a geometric argument, we do normally put the reason. So angles in a revolution, although if you don't feel like doing that now, today I'll give you off. So now we have to do some algebra, and we have to say, well, we've got 1x here, another x here, and 2x there. So in total we have 4x. And then what is minus 10 plus 20? I think that is going to give us 10. This reminds me of our last module on equations and inequalities. Okay, so now we have to solve this. And in order to do that, we take away 10 from both sides. If we take away 10 from both sides, you'll notice that we get 350. And now I have to deal with this 4. And so I have to divide both sides by 4 and my calculator might help me out here, 350 divided by 4. And that is 87.5 degrees. Shout out to Nizole, to Guguletu, to Letlenkhonolo, to Mbali, to Kiribona, to Numvoha. You guys are on the money. Well done, guys. Well done. Okay. I think it's time for a brain break. And so, guys, what I'm going to do is I'm actually going to lead you through a new brain break. If I can figure out where the screen sharing tool is. So I want you to stand up, step away from your desks. I'm going to say stop share. So hopefully most of me is in the shot. And I want you to stand up. Let's have a look. You see me. Okay. So what I want you to do, everyone, I want to, you can turn your cameras on if I can, so I can see all your fantastic faces, if you can. And what I want you to do is, I think I'm crossed over, but I've got my right hand in the air, and I want you to put your right hand on your nose. And then I want you to take your left hand, and I want you to put it on your right ear like this. So you're in a rather strange position. And now what you're going to do is, you're going to take your left hand, which is here, and you're going to put it on your nose, and then you're going to switch this to your other ear. See if you can do that. And now see if you can take this hand, which is your right hand, take it back to your nose and switch to the opposite ear. And see if you can do that. This forces your brain to really think, because you're crossing your, I think you're crossing your midline or something. And if you do this lots of times, you can switch back and forth like this. And yeah, it's harder than it looks. I'm sure you can. If you found that hard, well, if you found it easy, give a thumbs up. If you find it hard, give a thumbs down, because I suspect a lot of you would have found that quite difficult, because it is hard the first time you do it. So let me see in the chat. Thumbs down was hard. Thumbs up was, what do you mean, man? That was easy. I think, yeah, it is hard. It is hard. But it's, you know what it's designed to do? Is it's designed to take your brain away from the maths and let you focus on a task where you can't think about anything else except that. And I find that it's a very nice way for students to forget about maths for a minute, because it gets your brain so occupied. And it's very helpful in double lessons for students to stand up and do something a little bit different. Okay, well, since you've done a couple of those, I think I'm going to let you do all three of these by yourself now. So same idea, same concept, but I want you to solve for X in each of the following things. And then I want you to put your answers for A, B, and C in the chat. So we're back doing it again. And we're back from our brain break, and we are good to go. And I will give you 3 minutes. I think 3 minutes is fine. So at 18:43, so 3 minutes. Can you do this in 3 minutes, guys? Let's see. And I think what we're going to do is, oh, we can squeeze in maybe one more question after that. I see the first answers are coming in. So we kind of know that this has to be 360. And if we add these guys together, we are going to get 240, which if we take away that from each side, we get 120. Yeah. Nice. Well done, guys. I can see that you're starting to feel more and more comfortable with this. So some of you might be getting a bit sneaky and thinking, oh, I think I can do this faster. What you could do is you could say, well, I know what 80 and 70 is, it's 150. And I know what 4x and 3x is, it's 7x. And so obviously the reason is still angles in a revolution, but that speeds it up a little bit. And I think that's not a bad technique sometimes when you can add it up on the fly. Okay, so I see some people are coming in with answers for B already, which is great. Keep them coming. And then also to do C, please. I'm going to give a little bit more time for B. I feel like that needs a bit more time. So I see a lot of people say it's 30. Let's see if we can agree. So if I take away 150 from both sides, 360 minus 150 is 210. If I divide both sides by 7, then I will get 30 degrees. Okay, this last one looks like a bit of a mission. Now, I'm being even more sneaky now, but I know that these things all add up to 360. So that's the same thing argument we've been using all along. If I want to make my life a bit easier, what I could do is I go, well, there's a 3x, a 2x, and a 3x. And so maybe I could just say that I know that that adds up to, well, 8x. Let me go back to my pen. So 3x plus 3x, that's 8x. And what is 30? Oh, wait, I left something out. Oh, golly gosh. So this is 10x. So all these together is 10x. And what's 30 minus 20? It's just going to be 10. And so now we take away 10 from both sides and we get 10x is 350. And if we divide both sides by 10, we should get x is 35 degrees. And I think a lot of us have got that right. So that is looking great, guys. I think all of you seem like you've got this, which, I mean, even if you've got a little error here or there, most of us are on the right track. I'm going to leave these ones out because I feel like you have got these. What I want to do is I want to challenge you guys with a couple of, we're going to do 5 more minutes and then we're done for today. I want you to try and solve these two. C and D. What is the answer to C and D going to be? And the fact or the theorem that we're going to use involves something I mentioned earlier in the lesson. And so can you do these two? Can you solve for X in these two questions? I'm going to squeeze in a few. I'll let you go from about 10 to, but I think we're on a good run, and I just feel like students would really benefit from a recap of these ideas. Is C vertically opposite? Ruha, it is indeed vertically opposite. You can see these two things crossing over each other. And when we have vertically opposite, we have two pairs of angles. This one is going to be equal to this one, and this one is going to be equal to that one. And so how can we use that? If we know that 3x plus 10 is equal to 4x plus 5, I think we can write that as an equation relationship. And the reason, the official reason is just, we use the abbreviation vertically opposite angles. So there's that fancy word angles, the abbreviated form, and then the vert dot op dot are just contractions or shortening of the word vertically and opposite. Yeah. So now how do we solve this? And how do we solve D as well? I'm going to give you a bit more time. I'm going to stand up. Ooh. So in this first one, I don't see the answers for C quite yet. I see our answer for D from Lorato. I think you're on the right track there. So what I'm going to do for C is I'm going to say I'm actually going to focus on dealing with these two first. And I'm going to take away 3x from both sides. And that is going to leave me with x plus 5. Because, yeah. And then I'm going to take away 5 from both sides. And then I end up with 5 is x. So, or x is 5. So in C, I get x is 5. What do we get for D? You guys are so good because you recognize that these are also vertically opposite angles. And so this one over here must be the same as this, but you know already that that part is 40. So what does this remaining part have to be? Well, I mean, you don't even have to do an equation. You could, but you basically know that that relationship must be true because of vertically opposite angles. And so x must be 50 degrees. Yeah, that is awesome, guys. Okay, so what we're going to do now is we're going to bring the lesson part, although some of you will stay on the line to ask additional questions. But basically, if you're feeling okay so far, we're going to ask, Miss Anya is going to put the link to the fun quiz in the chat. And those of you who feel comfortable will go off and do that. And once you've done that, you are dismissed for the evening. You're done. So when you leave us, you can say goodbye and we'll say goodbye to you. For those who would like to ask a few more questions, we're going to stay online and I'm just going to answer those questions. But basically, for those who are ready for the quiz, I'm going to say goodbye. It's been great teaching you tonight. I hope that this has been helpful in just bringing some of those grade 9 and grade 10 geometry ideas to the front of your head. We will need to do a little bit more revision from grade 10 especially, and then we're going to head back to circles properly from the next lesson as well. Ms. Anya makes a good point. Make sure you are signed up into the Watobe website. So you have to sign in to the Watobe website to do the quiz. And so if you aren't seeing the quiz when you go to the link, you may need to sign in to see the link. But we'll stay online. If you're struggling to get in, then we will stay online. Okay. Thank you, Lorato. It was so nice teaching you. And thank you for your enthusiasm and always participating. I think that is really great to see. And so, yeah, go and enjoy the quiz and we will see you on Monday. I look forward to seeing you on Monday. Okay. And then students, if you would like to ask a question, I would love to hear a voice or for you to raise your hand. That would be awesome. I am available to take questions now. I'm happy to do anything that you're uncertain of or any question that you just want to chat about. The floor is yours. We've got a good couple of minutes to use for that. For those who are going off to do the quiz, That's all good, and I hope that you find it fun as it's intended to be. But yeah. And yeah, anything from you? It's been a bit of a
I'm really chuffed with the learners tonight. I was very quiet, but I kept an eye on the chat the whole night. And I'm just so chuffed that you guys were able to see those vertically opposite angles and applying your theory. The moment when you can start applying, it means putting in what you know in maths. It shows that you're learning. So really, like from my side, well done. You guys really deserve it. I'm so chuffed.
You got a nice hand clap there. All right. Okay, well, I mean, I'm just going to go to a blank space, and then let's go to that. I'll just call this Pro Profs. If you have any questions, I'm quite happy to chat to you about them. I'm even happy to take some audible questions. Otherwise, we can say our goodbyes and just, pop on the mic to say goodbye for the evening, or pop us a goodbye in the chat. And then we know that you're off to do your quiz.